videos. Today, we're going to talk about the different fault movements in the tectonic plates. But first, let us understand the concept of deformation. Deformation is a process in which rocks change in shape, size, location, tilt, or break due to squeezing, stretching, or shearing. It is the dominant process in the formation of mountain belts. The driving force that causes all these phenomena is called stress, and there are three fundamental stresses that contributes to this event, which are tensional stress, compressional stress, and shear stress. These three fundamental stresses are the primary contributors for the creation of joints. Joints are natural cracks in the rocks produced by brittle deformation. The rocks on both sides of a joint do not slide past each other. Joints are formed due to tensional stress in a brittle rock. It can form when rock cools and contracts. If there is joint, there is also fault. Fault, on the other hand, is a planar structures resulting from brittle deformation, but there is a sliding between rocks. A fault wherein there is a sliding in recent geologic times are considered active fault. This fault can move again in the future and generate earthquakes. Faults are classified based on the movement of the rocks with respect to each other. In an inclined fault, the block of rock on top of the fault is called a hanging wall, while the block below that is called a footwall. Now there are four primary faults that happens even up until today. And those are normal fault, reverse fault, cross fault, and right lateral strike-slip fault. And now we're going to study this illustration. This is the fault block model, in which I'm going to demonstrate to you in these models that I have created today. Now I'm going to demonstrate to you how the strike-slip lateral fault works. Basically, it goes like this. As we can see in the shape here, it's plain, and in this side here, we can see that it's a bit curvy. Now, we're gonna pair it up with this thing here, which is a flat surface over its side. We're going to demonstrate to you how it works. So, this is the right and this is the left. So, basically what it does is something like this. It slides past each other, like this. During this event, a large amount of energy is released in the fault, and during that specific event, the primary effects of that specific release of energy can somehow cause large catastrophes, such as earthquake, and that earthquake can contribute to the different deformations of rock around its system. The next fault movement is called the normal fault. So what is normal fault? Now, normal fault is when the hanging wall moves down with respect to the footwall, it forms a normal fault. So basically, the normal fault goes like this. As what we've seen in the model, we can see that the center plate goes down while the other two plates goes up. So basically, it goes like this. This plate over here goes down while this plate is going up. So it goes like this. And while this plate over here goes like this. During the process, it also produces a lot of energy. Thus, this process can also cause earthquake. And the final fault movement that I'm going to illustrate to you today is the reverse fault. So what basically is the reverse fault? Reverse fault is basically if the hanging wall moves up, it forms a reverse fault. And today I'm going to illustrate that to you. The reverse fault is somehow connected or related to the normal fault itself, because the horse block, or this block over here, goes down while the other block goes up. So it basically goes like this. That's it. Thank you.